Can you all see my screen? Hello.
Yes, ma'am.
Okay.
Screens.
Okay. Okay. So we'll quickly finish the previous session, the future outlook and innovation. So in the AI is, as I told, like I previously mentioned, in the future there won't be any manual intervention for information security professions. When any cyber attack happens, rather automated, everything will be handled automatically. So AI threat response system will themselves update the security policy in the firewall and block any incoming threats. So the advantages are it will be superior threat identification, faster response time, enhanced threat intelligence, reduced alert fatigue, proactive threat detection, improved efficiency, and more resource allocation. The further thing is blockchain. Again, it is another security thing which is enhanced security measures. So as part of it, I'll just explain briefly. Is that the data will be transferred in a block of blockchains. It will be in the block format. So in case if one block is affected, the remaining blocks will be uninterrupted. So blockchain ensures security options and compliances activities and are tamper-proof and easily auditable. Blockchain distributes control instead of relying on central authorities, reducing single point of failure. So these are all emerging security, enhanced security measures. Other one is the Facebook has recently introduced the metaverses. So as part of this, so far, I mean, all these days, I think we you would have might seen it was there in the games world where we had a virtual reality, but it has been now introduced to shopping as well. So the metaverse is a virtual shared space where virtual reality, blockchain, and internet merge, enabling immense interaction, digital commons, and social networking. So since the metaverse has is a virtual reality which has been emerging, I'm not sure if anyone has visited Dubai. There is a science museum there, and it's full of this virtual. I mean, they have so many of demo there about this virtual reality, and for the future evolution. So this is since the virtual reality has evolved. So again, there are some threats which will be coming, which will be raised because of this metaverse introduction. I mean, in usage. So all those which we have following so far, like biometrics security and other things, we will be try to be redefined in the metaverse virtual reality space as well. So that is again redefining of cyber security in metaverse. So this is how you can see, like in future what will happen is you can do shopping virtually. So in the space you can click the item and then you can put it in the shopping basket. Actually this is already in place. It is not that is going to come in some places. It's there, it's in the trial period. It's all in place. So conclusion and final thoughts. So, cyber threats continues to evolve. Staying ahead of cyber security trends is essential. The advancement in technology brings both opportunity and vulnerability, making adaptation critical in safeguarding digital world. Securing cyber safe space is a shared responsibility among individuals, businesses, and governments. Everyone plays a key role in resilience through strong security habits and defense and policies. As cybersecurity risks cross borders, collaboration, and utilities are strong defense, we will work together to let cyber threats divide us. Thanks. So what I have covered in this slide is not in depth. I have just covered overall what are the things, what are the encryption, what are the level of securities. I have in person I have worked in the RSA encryption. So in the software I have worked it. If anyone has any doubt on that, you can ping me. I'll pass my email ID to sir. So here I have just covered overall idea to have an idea. So for further things, you can either contact me or everything is available over internet. You can even surf yourself and read through it. Any questions? I have a PDF document of what all is being done in this today's session. I will forward that also to sir. He will forward to you. If you're interested, you can go through that. So the next topic is cloud and IoT security. So what is, again, it's a cloud and IoT security. What is IoT and cloud computing? So the IoT is Internet of Things, and cloud computing. They always mostly they work together to power many of modern systems we rely on. Let's look at how these technologies are connected and why securing them is so important. Both IoT and cloud computing are connected. How they are connected? So, for example, IoT refers to the billion of devices that are connected to the internet, from the smart home gadgets to industrial machines. So these devices, they collect and they send data continuously. Where do they send the data? They send this data, this need to be sent to the cloud computing. So cloud computing is like a remote storage and processing center for all the data IoT devices collect. The cloud provide storage, computing power, and security to manage all this data effectively. So how do IoT and cloud work together? As I told earlier, IoT will be IoT collects the data from the device in the real world, like sensors and smart devices. Cloud computing processes and store this data. It helps company to use this data to make decisions, improve operation, and stay competitive. So obviously, as I said, as the technology is emerging, there are advantages, there are disadvantages. There are some security challenges which are, I mean, which we face. So as IoT devices collect huge amount of data and they rely on cloud system for processing and storage, the security concerns becomes.
Ma'am, please change the slides, ma'am. It shows the previous session slide. QA.
Okay. Oh, is it not? Can you see my screen now? Can you see my screen now?
Yes, ma'am. It's visible.
Okay. Sorry, I'll exit and come back because I'm okay. Now it's okay. Fine. So as I told, the security challenges. So what is IoT and cloud computing? There are some security challenges. First is data collection and privacy. So the IoT devices gather sensitive information. For example, if for example I told the previous example, like the temperature is controlled in, I can control my home temperature for my office. So always, if you are installing any app, the first thing it asks is access to the location. So you are storing the location where you are going, what time, where you are. So example location, if you are accessing any health, there are many devices which have evolved now. Like for diabetes, there is a patch which no, I'm again not sure whether it's there in India, but in UK it's very common. For any diabetes patient, they have a small device which will they stick to their arm, and that device will continuously they will try to get the blood sugar level from the when it tries to get the blood. How it detects, I'm not aware of that, but it tries to get the blood sugar level and try to update in the app. So whenever the blood sugar goes above a particular range, it will alert the user, whoever that user is, it will alert it. So so such apps like the medical apps, the home appliances apps, they are collecting your location and healthcare data continuously, which can be targeted by hackers. So securing this data is very important. The next security challenge which we can face is infrastructure security. So with many IoT devices connected to the cloud, protecting the cloud infrastructure itself becomes more challenging. Again, thing is a complex security requirement. You can see, I have shown in the previous slide the 5G network, how complex it was. The user, the IoT devices were the below layer, on the top, the tower, and then ISP layer. So it is getting a really a complex, the infrastructure is getting a complex. Since both IoT device and cloud platforms are diverse and distributed, maintaining consistently security across all these systems is getting harder. Now coming to challenges of cloud security. So you can see from the figure, there are many challenges. I have listed some 11 challenges. I will try to go through the important ones which affects. So as the business is increasingly rely on cloud computing, it's important to recognize the various security risks that can compromise the integrity of cloud environments. So cloud platform offers significant benefit. They also introduce new challenge in terms of securing data and application and infrastructure. The first thing is insufficient identity management. So poor management of access control and authentication mechanism can lead to unauthorized access to sensitive data and systems, causing significant security breaches. The next one is insecure interface APIs. So vulnerability in the cloud interfaces and APIs. So what is API? So see, if we are, I don't know if you have used AWS is a cloud, it's an Amazon thing. So when we are interacting with a cloud, the cloud provides an API. It's nothing but in C we call functions. So the user interact with the clouder with APIs. Okay. So vulnerability in the cloud infrastructures and the APIs can serve an entry point for attackers, compromising the security of entire system and potentially leading to data leaks or unauthorized access. So this makes us to learn that while developing the API itself, security aspects has been considered so that it's not vulnerable. So previously, most of the design, how it used to design is during system design, there will be a security model separately and API interface model separately. But with the increasing demand, with the increasing technology, all thing evolving, now the security is being integrated in each and every APIs what is being generated. So, so that is what insecure interface and API. There's another challenges. Misconfiguration and inadequate change control. So incorrectly configured cloud environment can lead to vulnerability, allowing attackers to exploit weakness and gain access to critical system. Say for example, if a port is opened by mistake, hackers can gain access to the database server through that port and collect the information. The next one is unsecure third-party resources. So relying on third-party services or resources without adequate security checks can expose business to risk. As vulnerability in the third-party system can be leveraged by attackers to breach cloud environment. So whenever an organization adopts an off-the-shelf software, they has to undergo security assessment before bringing them to the IT estate. So here in UK, there are some sectors like defense sectors, there are some security sectors. So before hiring any engineers, they have to undergo several security clearance in UK. So they don't hire people without undergoing those checks. So this is one of the essential thing that if you are working with an unsure third party resources, we have to make sure that the third party resource itself, he or she is not an hacker. So that's why the security clearance is very must. Coming to the challenges, IoT security challenges in the IoT. So as the figure shows, there are many challenges. Again, I am going to highlight few of them. So as the Internet of Things, IoT continues to grow, connecting more devices to the internet, The risks associated with IoT securities are becoming increasingly critical. With millions of devices collecting, transmitting, and storing sensitive data, ensuring that the security of this system is essential. So the things which I am going to highlight now is data privacy and integrity. So data privacy and integrity, so ensuring that the confidentiality and accuracy of, mostly this session is a vague section, it's mostly theoretical. So please bear that it's a bit vague. So data privacy and integrity. So as part of that, ensuring the confidentiality and accuracy of data transmitted between IoT data is very important. Nowadays, the data are transferred using Bluetooth from any wearable device to IoT server. So if sensitive data is exposed or manipulated, it can have serious consequences. For example, in a healthcare IoT system, for example, in a hospital, we are using a healthcare IoT system. If the data from the medical devices like heart monitoring is tampered, then it could lead to misdiagnosis or inappropriate treatment to the patient. So it can lead concerns for patient safety. So breaches in data privacy could also expose personal information, leading to identity theft and frauds. The next security challenge with IoT is insecure data storage and transmission. So we have seen that IoT devices often handle large amount of sensitive data, but insecure storage or unprotected transmission of this data can be exploited by hackers. If you don't have proper encryption during the storage and transmission, this device can become easily targeted. So in fact, these days, so that's why, as I told earlier, in fact, these days, the security experts advise to encrypt the data not only during the transmission of data from one system to another, but also when we are in the storage, during storage also, in the cloud also, they want the security measures to be followed. The third challenge is what we face is lack of visibility. We all know that there are lots and lots of IoT devices deployed across various industries. Say it will be in millions. So with so many devices over the network, it's really difficult to maintain full visibility over all of them. It's not that suppose there are millions of devices in the network, there are chances that few devices may be, some devices may go unmonitored. So the devices which are not unmonitored, the hackers can easily target those devices and try to exploit it. For example, smart home devices like thermostat or security cameras might have vulnerability that are overlooked. If attackers compromise these devices, they can use them to gain access to the parts of the network or even spy on users. So it is advisable that regular monitoring and security audits are necessary to keep track of all connected devices. The another security challenge is botnet attack. So what is botnet? I hope I think I have seen nowadays in India, the HDFC Bank, they have started using chatbots. So if I think that name is the chatbot name is called Eva to answer any customer queries. So if there is botnet is a network compromised IoT device can be used to launch large scale attacks such as denial of DOS attacks. For example, in September 2016, it is not in India, but it's somewhere else, a botnet called Mirai botnet infected over 6 million IoT devices like cameras and DVRs and launched a DOS attack on major security service provider. The attacks caused a widespread outage, impacting services like Twitter, Netflix, and Reddit. So these kinds of attack can lead to financial loss and disrupt services for business and consumers. So botnet attack is another challenge which IoT security can face. Another one, as usual, ransomware attack, which is common everywhere. So even IoT security, I mean IoT can face the ransom attack. So IoT devices can be vulnerable to ransom attack. A recent example of this is Baltimore City ransom attack, which happens in 7th of May 2019, where a city government system was locked down and vital services were impacted. So as part of this, when this attack happened, the entire Baltimore City government services like payments and real estate transaction were disrupted, and the hacker demanded about 76,000 US dollars. US dollars, though the city refused to pay the hackers that amount, but it took about 18 million US dollars for them to recover over a period of time. So you can imagine the financial impact of a ransomware attack. Ransomware is very common nowadays. I told even in my company when it was affected, they demanded money to release all the software. Fortunately, all the software we had a backup, so we didn't pay the hacker, and the IT infrastructure they tried to recover themselves, but again it took 10 days, so it's again a 10 days business loss. So that's why similarly is it the same incident has happened into 2016, which is an ransomware attack, which is a challenge with the IoT. Now coming to, so we have seen the challenges in the cloud security, we have seen the challenges in the IoT securities. Let us now go further on cloud security landscape. So the cloud security is, so what is a cloud security? It's nothing but it's a set of practices and technologies used to protect the cloud-based system. Uh, so it is to protect the cloud-based systems, the data, what is in the cloud, and the applications. So in the cloud, just like a traditional system, security is based on three main principles. So the cloud security is nothing but, as I said, it's a practices, and those practices and technologies are used to protect the cloud-based system. So it follows on three main principles. One is confidentiality, integrity, and availability. That's why this triangle they call as CIA triangle. So a cloud security landscape is based mostly on CIA triangle, which is confidentiality, integrity, and availability. So what is confidentiality? This means that only authorized people should be able to access certain data. For example, sensitive data should be kept private and only accessible to those who need it. Sorry, 1 minute. I just switch off my phone. Yeah. So the cloud security landscape, it is based on the CIA triangle. So this means that only, what is confidentiality means? This means that only authorized people should be able to access certain data. For example, sensitive data should be kept private and only accessible to those who need it. The next one is integrity. This ensures that the data is not changed or modified by unauthorized people. Suppose if I am an admin, and if I am not admin, suppose I am an admin and I gave the admin privilege of cloud to my friend, and he didn't have a good intention, and if we try to change the data of in the system, then that's not good. So that's why this, so integrity means it ensures that the data is not changed or modified by unauthorized people. The data should be stay accurate and trustworthy. So only authorized individuals can make changes. Availability. So availability means service and data should be available and accessible to legitimate user and should not be interrupted. For example, if you take like banking, everywhere, not only in India, in everywhere, we have previously we used to go to the bank and then try to do any transaction, but nowadays we are doing the transaction sitting from home. So if on and we I mean, we trust that the service is available always. Suppose if there is some issue happens in the cloud storage, whatever the bank is using, like HDFC or State Bank of India, so there will be an interruption in their service. So that should not happen. So that's why availability of service should always be there. So this cloud security landscape, it follows the CIA triangle. So apart from this CIA triangle, it also has some additional layers of security. So from the figure you can see. So as you can see, this slide, CIA is the foundation stone of the security in any cloud infrastructure, which is at the bottom. On top of that, CIA, there are several other layers of security that help protect and cloud system. These layers work together to make cloud environment safer. So the next layer is firewalls. We have already seen what are firewalls. This is some static configuration in the system, and it acts as a guard. So these acts as a guard at the entrance of the cloud. Firewall block unauthorized access while allowing legitimate communication to flow through. This helps protect system from attacks like we have already discussed in the previous section. The rules of cloud firewalls are constantly updated, unlike static rule sets followed by traditional cybersecurity methods. Though the traditional cybersecurity method also used firewalls, but that time it was static. But as the technology is emerging, the firewalls have also started updating the configuration. Constantly, it started updating its configuration. The next layer is proxy server and routers. The proxy server acts as an intermediary between user and the internet, adding an extra layer of security by hiding user's real identity. And what it does, it monitors requests for malicious content. So the router data traffic between the router directs the data traffic between different networks, ensuring that the data reaches the right destination securely. So I mean, so for example, an organization can have several data centers, routers. It can help direct any user queries to correct data center and fetch information from legitimate user. Above that, the layer is network control. These are the measures taken to protect the networks and connect the cloud to users. On top of that, further layer is software control. So ensuring that the software run on cloud system is secure, regular updates, patches, and security checks are necessary to prevent attackers from exploiting in this software layer. Then comes encryption. This is used to protect data by converting it into code so that only authorized user can read it. Encryption helps ensure confidentiality by keeping data safe during transmission and storage, so that even if it is intercepted, it can't be read. So coming to the cloud security landscape, so combining all the layers, like the foundation was CIA layer, which is CIA triangle layer, followed by that encryption, software stack and network control, firewalls, proxy servers, and any organization can create a strong defense against potential cloud security threats. So it's not that only these are the layers we can have in a security. These are only the security layers we can have. Apart from that, there are also another security checks which we can do is authentication and authorization. So what is authentication and authorization? Say, for example, if you're trying to access your Gmail account, when you enter the username and a password, only if the username and password matches, then it allow inside to go into your inbox. If it doesn't matches, then it will not allow. So authentication checks if someone who's trying to access the Gmail account, if it is of that person's Gmail account, And authorization is once it verifies that the password and username matches it, it allows it. That's why it's authorization. So these are another security steps: authorization and authentication. Next thing is audit and identity management. So same thing, authorization and authentication and authorization also happens in accessing the cloud storage as well, cloud computing as well, similar to how you use Gmail. Next one is audit and identity management. So audit, what it tracks user activity, ensures all actions are recorded, and identity management ensures that right people have access to rights resources at the right time, improving security control. The further things what we can do is security monitoring. So this involves continuously monitoring cloud environment for potential threats or unusual activity. So early detection of issues can prevent larger problem down the road. Next is security policy management. So this ensures that rules and guidelines are in place of how data and system are protected. Good security policy ensures everyone follows the right procedure, reducing the risk for security incidents. So suppose if an organization is decides to, in olden days we didn't have clouds, so most of the data in any, even in the software company, they used to have a server where they used to have all the data backed up in the server. They used to have one server and as a backup of that another server. But nowadays, due to the threat of cyber security and also uh, for access purpose, 90% of company, they have started moving to the cloud storage. So when an organization decides to move to the cloud, they have various options to choose. Like the clouds can be a private cloud, or it can be a public cloud, or it can be a hybrid cloud. So we are going to, so what the name you can get from the name private cloud means it is private to one company, one organization. So cost wise, it will be a bit expensive. Public will be accessed by many organizations. Hybrid is a combination of both private and public clouds. So now what we will do is we are going to discuss various security aspects of these various types of cloud environment. So private cloud. So a private cloud, as you know, is exclusively used by an organization. It gives a better security and control and customization. So in private cloud, data and application remain behind the firewall and are accessible only to the enterprise, making private clouds better suited to processing or storing sensitive data. So if suppose if it is a defense sector, then they will prefer to use private clouds because they don't want any of the data which is very very sensitive to the country to be shared with anyone. So anything which is in the private cloud is highly secure. Also, there is a greater visibility into security and access control because, and also the other advantage of private cloud is that the security things, everything is defined by the organization which is using that. So there is a greater visibility into security and access control because all workload run behind the customer own firewall. Say over a period of time, an organization decide data needs grow as customer grows. Suppose if an organization has opted, because it's a small organization and they have, it's a startup company, they have a very less data and they decided to go with the private cloud. But over of time, they felt like using a private cloud is very expensive. So they decide to move to the public cloud. So as over a period of time, as an organization need to grow, as a customer grow, then there is a flexibility of such organization to move non-sensitive data to public cloud. Say for example, product catalogs, training manuals of an employee, open source research papers, all this you can get even in internet. Even if you Google surf it, you can get it. So these are not sensitive information. So these are not sensitive information, there might be some of the document which are specific to a particular company. So these data can be moved to public clouds. It doesn't mean that public cloud is not secure. It is secure, but comparatively compared to the private cloud, public cloud are bit less secured. So this next comes the public cloud security. So there will be a storage, database, network security, enterprise. There will be many. It's not one customer. There will be many customers. So in the private cloud, it's one organization which will be accessing the cloud. But in the public cloud, the customers can be multiple customers will be accessing the same public cloud. So public cloud is a cloud service provided by a third party where multiple organizations share the infrastructure and resources accessible over internet to anyone with an account. So if there are multiple customers, they will have a separate account and they can access the cloud. As I said earlier, AWS provided by Amazon, Azure provides by Microsoft, and GCP is provided by Google are some of the familiar public cloud providers. These are the examples of public cloud providers. Even Amazon also provides private cloud, but commonly used nowadays is AWS provided by Amazon, Azure, and CGP by Google. So many companies mistakenly assume that cloud security is solely the suppose I'm an organization head and I'm planning to move all my data to a cloud. What many companies, they are in under wrong assumption that once I try to move my data from my local network to the cloud, they think that the security responsibility is only of the cloud providers. No, it's wrong. The security aspects is of the organization which is using it. So the many companies mistakenly assume that the cloud security is solely the cloud provider responsibility. However, providers secure the cloud infrastructure while organizations are responsible for protecting their customer data and how they use the cloud services. So controlling data in the cloud also depends on organization ability to control who can access it. That they should have a restriction on who can access it. Most threats to the data hosted in the low cloud comes from compromised internal accounts. So and also the threats come from incorrect configuration of public cloud services can be a major security risk, as it can make the cloud vulnerable to various attacks. So this can cause data to publicly exposed, manipulated, or even deleted. So we have seen private cloud, public cloud. Next comes the hybrid cloud. So hybrid is nothing but, as a name implies, it's a common, an organization is trying to use both public cloud and private cloud. So what the organization will try to do is any sensitive information they will try to keep in the private cloud, and they can move any non-sensitive documents to the public cloud. So when both public and private cloud exist in the same time, then it is called hybrid cloud. It allows user to run application and store data across multiple environment. So by offsetting the non-sensitive information in public cloud, obviously the organization gains some cost benefit. So why people are going to hybrid is when they move, they started using both. They will have some cost benefit. So they balance the security and cost in this way. Since the data is stored in the distributed fashion and in multiple cloud environment, this reduces the risk of total loss from ransomware or malware attacks. Imagine all data is stored in one place and the attack happens, it has mass impact. And another advantage of using hybrid cloud is we can also share the sensitive in multiple clouds. So in case if the public cloud is attacked, unfortunately, if the public cloud is affected by ransomware, still the private cloud is safe. That's another advantage. So any unsecured hybrid cloud increases vulnerability. So solution like micro segmentation help close security gaps within the network reconfiguration. So we have seen private cloud, public clouds, cloud and hybrid cloud. Now we are going to see some emerging trends in the cloud security. So in as part of that, the main thing which pops up is, I think I have not put the slide for that. So the cloud security for the, I mean, emerging trends in the cloud security is it. Like I said before, these days security is not done after the software developments come. I have mentioned earlier that the security is part of any API development. It's embedded right from the beginning of software development lifecycle. For example, a software stack has many interfaces. When a data is transferred from one interface to another interface, the data is encrypted. So not only globally but locally also, when the data is transferred from one interface to another interface, the data is encrypted, and the receiving interface has to decrypt it and use it. So uh, this rise to a new development methodology, and this is called DevSecOps. So DevSecOps means development. At the same time, security is not compromised and while doing the operation. That's why it's called DevSecOps. So I have mentioned about the AWS cloud. So Amazon, it uses the AWS Guard Duty and AWS Security Hubs as a couple of security services that are located in the AWS. So if you see here, when a user here at the bottom, you can see when it tries to access the Amazon cloud using Amazon SNS, there is a block which you can see which is called CloudWatch event. So the cloud, whenever a user tries to access the Amazon cloud, there is this CloudWatch event which will always start generating logs. They generate logs. Okay, it will be very frequent. The logs will be generated for everything. Logs will be generated. What time the user has, what time he has accessed the cloud, what he's trying to access from the cloud. For everything, logs will be generated continuously. What this Amazon Guard Duty does is it monitors that log, and if it if it finds that there is some alert, it will pass that to via this Elasticsearch to Kibana. So what is the role of Elasticsearch? It converts that log which is generated by the CloudWatch event in a format which Kibana can represent, and then any alerts can be, then further action can be taken based on that. S3 bucket is nothing but it's a storage container. So AWS Guard Duty here helps to secure workflow for DevSecOps. DevSecOps means development, security, and operational. And Kibana is a cloud monitoring tool used by ops people to monitor the AWS cloud for any malicious attacks. So it's not only for the malicious. So it is not only used for the CloudWatch event is not only used for the malicious attacks, but also the logs can be used for tracking any network and performance issues. So that is another aspect which which is already which always a software in a software development it is taken into account is performance and network performance issues. So if the overload is if the load is more and the cloud is not able to respond, if you're trying to access a cloud from the cloud and it's not able to access immediately, that means there is a performance degradation. So those things can be monitor, and how it can be rectified. For that, they will be using the logs which is generated by the CloudWatch event. Now coming to the benefits of this AWS Guard Duty is it since by continuously it continuously, whenever any action is, whenever the AWS is trying to be accessed by an user, so it is continuously monitoring the cloud environment. So Guard Duty helps identify potential threats early, enabling team to take action before the attack escalates. The next benefit is that automated security monitoring, that is the Guard Duty machine learning algorithm and integration with threat intelligence reduce the need for manual intervention, ensuring that continuous automated security monitoring happens. And the other advantage is integration with CI and CD pipelines. So guard duty can integrate it with the DevSecOps pipelines to monitor code repository, build environment, and deployment for suspicious activity. This helps maintaining security across entire software development cycle. So CI and CD pipelines, I'm not sure whether you are aware of those terms. So initially, I mean, in olden days, most of the, suppose in a company there is a, for example, I'll take my the development what I am doing. We are working on a STB, so it will have a various component like the moment the tuner, the box is connected to RF feed, so it will have a tuner component, it will have a media storage component, it will have a security component. So there are various teams. It's not that the same person works on all the components. There is a various team working on different modules. So, and whenever a feature or any development happens, we have to integrate to the full stack. Full stack will be in the versioning control. So to integrate that, there are some Jenkins is another tool which provides may like pipelines to integrate automatically. Suppose if I'm developing a code A, and it undergoes again various process like code review process. Once the code is reviewed and is all okay, then I check in that too in my branch in the Git. From there, there is a I mean the company will have a CI pipeline integrated. What it will do is we have to raise a ticket. It will automatically that code and will try to integrate to the main stack. So guard duty can be integrated with the DevSoc application to monitor repository. That is another benefits of AWS guard duty. Then next benefit is actionable findings. So guard duty provides detailed findings that can be acted upon directly, either manually or through automated workflow, helping streamline incident responses. So these are the advantages of Amazon guard duty. The next topic on this will be serverless architecture. So what is a serverless architecture? So the name says serverless. That means there is no server. That's a English meaning. If you ideally take the meaning, it will be no server. So what is a serverless architecture is a way of building and running application without having to manage server. So if I'm an organization, I'm trying to access a cloud, I don't need to manage the server. So server is sorry. So it's a way of building and running application without having to manage the server. In this setup, developers focus on writing code while the cloud provider automatically takes care of the infrastructure, scaling, and server management. For example, if you are building an online photo storage service, you can upload photos to the cloud platform, and the platform will automatically handle storing, processing, and delivering the photos to the users as needed. So this allows you to focus on functionality, saving time and money, because you only pay for what you use instead of maintaining a server 24/7. So that is what is called serverless architecture. So it says pay only for execution, zero maintenance, high scalable, highly available, quick turnaround. So these are all features of a serverless architecture. No server management. So developer don't need to maintain or configure server. The cloud provider handles provision and scaling. Function as a service. So applications are built on small independent functions that run only when triggered by events like database updates. Then the next feature is automated scaling of the serverless architecture is automated scaling. Serverless applications scale up or down based on demand, ensuring efficiency. Pay per using price. So costs are incurred only when functions are executed, reducing expense for idle use. Fully managed by infrastructure. So the cloud provider takes care of provisioning, security, and maintenance of computing environment. For example, AWS Lambda is in AWS is an serverless architecture example. Then integration with the cloud services. So serverless solutions can include database authentication, security token services to build complete application. So we have seen what are the advantages, features of serverless. What is a serverless architecture, and what are the features of serverless architecture? Now let us move on to what are the best practices we should follow in a serverless architecture. So the first thing is deploy API gateway for security. So API gateway act as a secure entry point, controlling access traffic and ensuring proper authentication to prevent authorization access in serverless application. Perform load testing. Conduct load testing to ensure, see, if suppose I am using a cloud storage, a serverless architecture from a cloud storage, unless and otherwise the cloud storage, they do frequent load testing. If along with me there are 100 more users, they join the cloud, then performance will be degraded. So they have to continuously load test to see that as and when more users are added to the cloud, the performance is not degraded. So conduct load testing to ensure serverless functions can handle heavy load traffic and mitigate risk of service disruption or overload, ensuring availability. The next best practices is manage code, not configuration. So focus on securing code deployment instead of complex infrastructure configuration to minimize vulnerability in serverless architecture. Start locally. So it's not that when you are started, I'm working on a product, I got just a requirement from the customer. It's not, and I just started working on that requirement. So the best practice is I should not start using cloud immediately and start dumping all my code in the cloud. First, I just try to work in my local machine, try and tested all the unit testing, whatever required. Once I'm confident that it has passed all the tests, and then we have to store that in the cloud. So that is what start working locally. Develop and test several applications in local environment to identify potential security vulnerability before deployment to the cloud. The next practice is use one function per route. Reduce the risk of misconfiguration or security breaches by isolating functions per route. So enhancing control over permissions and access. Don't rewrite code. So avoid unnecessary code rewrites as they could introduce new vulnerability. Instead, optimize and secure existing code to maintain integrity and minimize security risk. So next comes significance of IoT device. So from the graph, you can see it's a predicted global IoT market share till 2033. So the Internet of Things is, you can see from the graph 2023, it is only, you can see the size on y-axis and year on the x-axis. That 23 is, we have just started using it. I mean, we are using it, but over the years, when it reaches 2023, it is drastically increasing. So the IoT is growing as an incredible pace, and it's expected to worth over $3.4 trillion by 2033. This growth is being driven by increasing use of connected devices across many different industries. We are seeing more and more IoT devices like wearable smart home systems, industrial tools everywhere. So right now there is about 16.3 billion IoT connection around the world, and that's expected to rise to more than currently we have about 6.3 billion IoT connections around the world, and that is expected to rise to 27 million by 2025. So the data what I am saying now, it has been taken in the year of 2023. So the expectation was by 2025 it should have raised to 27 millions. Is currently we are in 2025. So I am assuming like the IoT device has risen to 27 million now. So you can imagine how much it will rise by the time it reaches 2033. So in the industrial world, IoT is making a big impact, especially in the sector like manufacturing, oil and gas, and logistic. It's helped companies improve efficiency, predict when maintenance is needed, and make smart decisions based on data. So the growth of industrial IoT is making it easier for machines to communicate with each other, making production process more efficient and supporting the shift to industry 4. Plus, as the industry focus on sustainability, IoT are playing a key role in tracking energy use and helping to cut down on emissions. So as the IoT, so from the graph, you can see from 2023 to 2033, it is going to be a drastic increase in use of IoT market. So anything which is developing obviously will have security risk as well. So the common security risk and vulnerability what IoT device can face is being listed in the picture. So first thing is inadequate authentication and authorization. So risk is the weak authentication can allow unauthorized access to IoT device, compromising data and device behavior. There is an example, as I said earlier, in September 2016, the Mirai botnet exploited default, credentials, launching a massive denial over service attacks on website of security expert. The next security risk is lack of encryption. So unencrypted channels expose data to interception. So a thermostat transmitting unencrypted data could reveal daily routines. So it's must that we make a practice in the IoT device that all the data are encrypted. Firmware vulnerability. So flaws in the firmware can allow remote or unauthorized code execution. For example, Blueborn is a type of security vulnerability with Bluetooth implementation in Android, iOS, and Linux and Windows. It affects many electronic devices such as laptops, smartphones, and wearable gadgets. So this is if we have some loophole in firmware, that can also be a risk with the IoT devices. Insecure API. Insecure API can expose data or allow unauthorized actions. For example, a weak API in a smart lock could let unauthorized user unlock door remotely. Next is physical tampering. So physical access to the IoT devices can lead to tampering of data or theft. Example, a compromised smart meter could lead to inaccurate billing or power theft. I think this always happens. Most of them, people do is purposefully tampering the electric meter in India to have. I'm not sure now, but when I was in India, I have seen a lot of cases where people try to tamper the electric meter. So that is another IoT risk. Supply chain risk. Malicious actors can compromise the supply chain, injecting malware. For example, in 2017, NotPetya attack exploited a compromised software update from a vendor. Another software risk is on legal devices and patching challenges. So older IoT device may lack security features or proper updates. It's not that IoT is not it is coming now or it is going to come in the upcoming years. There might be IoT has been used for years now. So the initial IoT device which have been developed, they might not have the security patches which are available currently. And I think initially when the devices are developed, they don't consider all. I mean, generally they try to consider it, but most of the time they lack in considering all this factor. For example, the current product what I'm working on a STB product. So currently I am working on a box which is IQ5, and this product we started developing 10 years before. So when we started developing that first product, which is IQ3 box, we didn't use. Currently, we are using the Broadcom ARM.
பேக் எடுத்து வைங்க. எல்லாமே கடவுள் கடவுள் கிடைக்காது. உன்கிட்ட பல தடவை சொல்லிட்டேன், உன் பொருட்களை நீ தான் எடுத்து வைக்கணும்.
So when we started developing that box, there were few. Nowadays, most of the upgrades they are happening over the air. So we do consider how to upgrade the box, everything like even from bootloader till the firmware, how to upgrade it. We all the factors are considered. But when we started developing the IQ3 box, we had a limitation. We didn't consider all those things, and the boxes are all deployed in the field now. So those devices, if the boxes are not deployed in the field, we can take that box and upgrade with whatever security patches is required. But those boxes are already in home and in the field. So those boxes will not have all the security updates which the current box have. So that is what the other thing is. Legacy devices and patching challenges. So older IoT device may lack security features or proper updates. Next comes the privacy concerns. Insufficient privacy control can lead to data leaks or misuse. For example, a fitness tracker leaking health data could violate privacy laws. We may consider that what is going to cause leaking just a fitness track, but it is again as per the laws what I mentioned earlier, as per the GDPR and other laws, these are again a violation of privacy laws. So to mitigate these risks, startup must prioritize security throughout IoT development, including strong authentication, encryption, and securing coding and regular updates. Emerging trends in IoT security. So we have seen what is an IoT, what is a cloud computing, what are the challenges in the IoT, what are the challenges in cloud computing, and we have also seen the security risk with IoT. Next is coming is emerging trend in IoT security. So as part of this IoT security, edge computing is something which is a trend, emerging trend. So what is an edge computing? So edge computing is a method of processing data closer to where it's needed, rather than sending it all to central cloud or data center. This helps improve response time, save bandwidth, and increase security. So it is, see, as we have started using IoT, we are using cloud storage. So as we are using cloud storage, so as per the trending thing, edge computing, what it says is edge computing is a method of processing data closer to where it is. Suppose if I am in Madurai, I would like to find something which is closer to Madurai instead of sending that to UK. So that's what it says. data closer to where it is needed rather than sending it all to the central cloud or data center. So this has got its own advantage, which is it improves the response time, saves bandwidth, and increase security. So let's break down the various component in edge computing, which is data generation. So devices like sensors, smart devices, or machine create data in real time. For example, a smart thermostat collects temperature data, or a security camera captures video footage. So that is what the data generation will do it. Local processing edge. So instead of sending all the data to the cloud or data center, edge computing processes the data right where it is created. For example, a security camera might analyze the video locally to detect motion, so it doesn't have to send everything to the remote server. This keeps the data safer and fast. So real-time decision making. By processing data locally, edge computing helps make quick decisions. For instance, in self-driving cars, the car sensors analyze the environment instantly to make decisions like stopping or turning. Or if it is an automated car, it can take decision based on the real-time data. So this is important for things that needs immediate response like cars or factory machines. So real-time decision making. Next is the data optimization. So before sending data to the cloud, edge computing makes it smaller and easier to handle. For example, a smart camera might only send important data like motion alerts and not long videos. So this will save space, reduces delays, and also help protect data by only sending what necessary. Next thing is cloud and data center integration. So once the data is processed, optimized, it sends to the cloud or data center for more detailed analysis or long-term storage. Since most of the sensitive data is handled locally, the risk of it being hacked the cloud is much lower. Machine-to-machine communication devices using edge computing can talk to each other directly. For example, a connected coffee machine might communicate with the water dispenser to start heating water when needed. So this is a communication happens locally, so there is a less risk of things going wrong in one central spot and harder for hackers to attack the whole system. So in short, edge computing helps device processes faster, safer by doing it closer to where the data is created instead of relying on much on cloud. So that is what an emerging trend of this, which is edge computing. I think we are done with this presentation. Any questions and answer? Any questions?
Thank you,
How to
ma'am.
manage the threat, ma'am?
I know that it's a very theoretical subject and it's a bit vague. So if you want to know in depth, then you need to go. I mean, you have to go read through full thing. Is what I can say it. In a session like
Okay.
this, I mean, a person can only give a brief idea of what are the things we can cover.
Hello.
Yeah.
Hello, Hema. This is Rajalakshmi.
Hi, Raji.
So I have no questions. Just I want to say you have delivered the session really great, and we learned a lot. And yeah, you explained many concepts using real-time examples. Just I want to say this kudos to you.
Thank you.
Great delivery. Great delivery, Hema.
Thank you. I mean, I didn't go in depth because it's all overall. I just want to cover the topics. In depth need to be done. It can't be done in 1.5 hours. For the in-depth knowledge, it's an individual who need to go in depth. But as I said earlier, I have worked on the RSA encryption algorithms. So if you have any doubts, you can ping me. I'll pass my email ID to sir. Or anything which is covered in this regarding how it is handled in the software, I can explain that offline. which can't be covered as part of this session. Any other question? Sir, do we need to continue it, or can we finish the
Oh,
session
thank you, madam.
earlier?
Thank you. Thank you for your wonderful presentation.
Okay, then.
Ma'am,
Thank you
there is
very
one
much.
question in the chat box, ma'am.
Chat box. 1 minute. Let me.
Sangasangaran?
Actually, it is asking that person, that Sabarinath sir from SRM, I think, is asking what is the scope for IoT in mechanical, ma'am?
Scope of IoT in mechanicals. I think see, some of the IoT sensors can be placed on machines to monitor. I'm just thinking, mechanics is mostly, is it motors? See, in mechanics, suppose take a factory, there will be a production area, right? So there will be appliances. Hello?
You can say example like car industries.
Car, okay, yeah. Yes, as I said, in mechanics in car industry, you know that nowadays driverless car are coming, has been in some country, in US and all, the trial has already been done. So in such industries where like car or automated car, definitely the IoT will be used there, like sensing of based on the map where to go, which direction to go. So it will be used in those car.
I think in India also we had a trial, no, for metro trains without drivers. Is it something related to that?
Yeah, we can also use. I mean, IoT is
IoT.
nothing but anything which is controlled by a sensor or which is connected to the internet, and we can control everything is classified under IoT. So yeah, maybe I can explore on that further and give the answer, but the immediate answer is yes, it can be. I mean, IoT can be used in cars and other things.
You can say this, Hema, you can say the car nowadays, latest car will go in nearby median. That time sensor may access and give the data to the driver, like that.
Yeah. Any other answer who can, I mean, who are in the call, I can also answer this question.
Sir, actually, industrial IoT is a separate session for Industry 4.0.
Okay, so will that be covered as part of that session? Will this be covered as part of that session? I hope that it will be covered, but I'll try to get the answer and then I'll pass it again to sir. Any other question?
If no further question means, we can wound the session now.
Okay, fine.
Okay, thank you, ma'am. Thank you for your
Thank you.
wonderful presentation. Thank you, ma'am.
Thank you.